would you do first? Operations inside the absolute value, not clearing anything, not distributing anything, are allowed. That part is allowed. So inside the absolute value, I can distribute as long as I know I don't take anything out and I don't take anything from outside inside. And then I have 3x minus 1. And now I know there is nothing else I can do. And don't erase it like that. I'm just making a point. I cannot solve this if I don't know how to convert it. It has to be converted into something plain and simple. How? Which type is it? Yes, which means I'm asked to find numbers whose distance from 0 is less than 20 or more than 20. You already said less than to me, and I'm asking, is it less than 20 or greater than 20?
Less than 20.
Good, so then where will I find a solution? Where will I find? I only need 2 words. In between. That's all I need. If you remember in between, then you will never make a mistake. So it's in between. So then please dictate. How do I write the in between? And I have to start from the left. In between what and what? Very good. Excellent. What do I write? Awesome. Awesome. That's it. That's the conversion. So if I want to solve this, I have to solve this. There's no other way. Okay, first step, please. Add 1, awesome. So negative, when I'm adding 1, good. I'm adding 1 to negative 20, I get negative 19. I'm adding 1 in the middle, I'm adding 1 on the right. Final step. I will divide all 3 sides by 3. So this is negative 19 thirds, and this is x, and this is 7. In interval notation, please. X is found in the following interval. What interval? Can anyone tell us?
Maybe a bracket. Negative 19 over 3, 7.
That's what it says. Greater than this, but less than that. Greater than this, but less than that. In between. Is that a... The equal symbol.
Sorry?
Equal symbol. When the equal symbol is there, we put the bracket. Is that okay?
Okay, okay. So whenever there's like
The equal symbol means included, so the bracket means included. If it's not included, we use the parenthesis. 5 times the absolute value of 2x plus 1 minus 3 greater than or equal to 9 as the second example. So what do we do now? Of course, absolutely, we have to completely clean it up. Yes, we have to move 3 to the other side. It becomes positive 3 plus 9, 12. Very good. Next step. Absolutely, we have to completely clean it up. Only now I can look at it and say, I know this is what type? Which one? Right. So there are only 2 options. Am I looking for in between, or am I looking for the outside? Of course. Which means, again, do not cross it out like this. I'm just making a point. So I'm looking for 2 different options. Completely separate that cannot be put together in one chain. So what is the first option?
2x plus 1 less than or equal to 12, 5. Negative.
Yes. If you say less than or equal to 12/5, then you include the in between.
And then the same thing.
Yes?
With the greater than or equals to or positive.
Excellent. Well done.
And that's because it's it was a negative, right?
It's because it's the outside. It has to be less than or equal to negative 12/5 or greater than 12/5. You cannot include anything in between. Is that okay? Good. So now I have to, you have two options here. Either multiply both sides by 5 and eliminate fractions and take it from there, or you move 1 and operate with fractions. Which one do you want? You want to multiply by 5? Fine. Always remember, don't be afraid of fractions. You can always eliminate them. Well done. So then we have 10x plus 5 less than or equal to negative 12. Remember to multiply everything by 5. 2x times 5 and 1 times 5 and then negative 12/5 times 5. So this is 10x less than or equal to negative 17 after we move 5, and x is less than or equal to negative 17/10. I caution you, I've seen it in tests and homework and so on and so forth. Some students change the inequality symbol into equal, into equation. Do not do that, please. Please. Okay, so the other option, same thing, multiply by 5. So we have 10x plus 5 greater than or equal to 12. In this case, 10x greater than or equal to 7, x greater than or equal to 7/10. And if anyone would like to give us a solution with a union in between. It appears that quiz 1 has disappeared. Yeah, Tiffany showed me something is wrong there, so I'm going to look. So you can finish up everything between now and Monday. I'm going to look and see what happened and why. Yes,
So we had to finish the quiz on Monday.
please.
Yeah.
And always bring all your questions to class.
Or the, oh no.
Okay. Any questions? Can anyone give us the final solution, please?
Is it, would it be negative, infinity,
Awesome.
then it'd be, negative 17
Awesome.
with the bracket.
Awesome.
Right. And then it'd be the bracket,
Awesome.
17 over 10. Then it'd be the.
7/10.
Oh, 7/10.
Very good. Awesome. Well done. That's all I needed. Okay, so one more time between now and Monday, I am please all chapter 1 factoring. I want to see those 5 problems from the factoring supplement, 5 problems, which I would like to look at on paper. I will go around and you will show me all those 5 problems that we did not do from the supplement. Yeah, the handout. From 5 problems on factoring. Because you're going to have an example like this on the test. So that's why I want to make sure that you all got the answer and you're happy with it. And quiz 1. So by Monday, Monday is it's the 18th. Okay. So our first test will include sections 2.1 to 2.5. I cannot even talk about the test before we finish it. No, I can because I don't want to commit. I don't want to commit till we finish, and then we'll talk about the the first test. Okay, so let's move on to a section so chapter 2 deals with functions and graphs. A lot of this is going to be a review for you, but we'll go through everything. So chapter 2, functions and graphs. In 2.1, we will review what a function is, so functions, the basics of functions, and how to read from a graph, and what is a function, and domain and range, the things that we know about, but I'm going to refresh our memory on these things. Okay. So we're gonna look first at 3 sets of bubbles. They are paired. And I'm gonna put some numbers in the first set. Let's say 1, 4, and -10 in all of them. 1, 4, and -10. And in the other one, in the second set, give me 3 numbers, any numbers you want, it doesn't matter. 0, 9, and -1. 0, 9, and -1, 0, 9, and -1. Okay. So this is called the first set, and this is called the second set. And let's say I would like to connect them, and this is important, how I connect these x to y values, of course. So let's say I connect 1 to 0, I connect 4 to -1, and I connect, let's say, -10 to 9. In the second situation, I'll connect 1 to 0, 4 also to 0, and -10 to -1. And in the third set, third pair, I will connect 1 to 0, 1 to 9, 4 to -1, and -10 to -1. Now let's analyze all these 3 situations. In the first situation, I see 1 corresponds to 0, 4 corresponds to -1, -10 corresponds to 9, and I could write 1, 0, 4, -1, and -10, 9. So I see that each x value, of course, these are all x values, and these are y values for all of them, for all 3. So I see that each x corresponds to exactly 1 y. 1 y, 1 y, 1 y. This is what is called a function. Furthermore, later on in this chapter, we will talk about, towards the end of the chapter, we will call this function 1 to 1. It has a very special property. Not all functions are 1 to 1. What does it mean? We don't need this for this test, but I will refresh your memory and we'll talk about it for test 2. It also means that for each y, there is only 1 x. For each y, there is only 1 x. For each y, there is only 1 x. It's not only that it's a function, but it also has the property that for each y, there is only 1 x. Okay, this situation, this x has only 1 y, this x has only 1 y, this x has only 1 y. Do we consider this a function?
No.
Absolutely function.
Oh,
Each x, only 1 y. Each x, only 1 y. Each x, only 1 y. Okay? What about this one? I found 1x that corresponds to 2 different y values. This cannot be a function. It exists. It's called a relation. But it's not a function. Is this one 1 to 1? No, because I found 1 y value that corresponds to 2 different x values. So I will say not 1 to 1. It's also written 1 to 1 or 1 to 1. Good. Now, let's look at 3 graphs. Here's one graph. We're going to discuss this graph at the end of chapter 2. Here's another graph. And let's say here's another one. let's start with the middle one. We know what this is. We've graphed it before. Maybe not in this class, but we've graphed it before in other classes. What is this? Of course, this is a linear function. I should have not written function or the name just yet. By the vertical line test, crossing the graph with vertical lines, I notice that each line crosses the graph in only one point. So let's say x equals 2, y equals 5. Let's say x equals -1 and y equals 1, and so on and so forth. That's why this is a function. By the vertical line test, I can say a function, yes. What function is this? I know we graphed it and we'll graph it again from scratch. This is what? It's a parabola. What type of function is this that has the graph of parabola? Quadratic. So this is quadratic. Very good. And is this a function? By the vertical line test, for every x, I read only one y value. For this x, I read only one y value. Is this a function?
Yes.
Of course, function. What about the first one that I graphed? It's not a function. By the vertical line test, let's say for x equals 2, I read two different values of y. I read 2 and 10, which means exactly this situation. 2 corresponds to 2 and 2 corresponds to 10. So I'm going to call this a relation. It's not a function, it's a relation. It exists, but it's not a function. Next concept that we need to talk about is domain and range. Extremely important because every time we are going to be asked to graph a function, the first thing we have to determine is the domain. Okay, so here is a graph. Please choose whatever you want from here, any graph. Just say a number, and we'll look at that. Let me just make sure that I started this. Yes, I did. Which one? 85, this one? Very good. Okay. So I see the graph of this function, and I'm asked to find its domain. I'm asked to find its domain. Good. So I see the leftmost point. It ends with full points, right? The leftmost point is right on top of -2 for x. And the function exists on the x-axis for any value. And then the rightmost point is what? 6. That will be the domain between -2 and 6. Because the points are full, I'm going to write a bracket, -2, 6. What is the range? The range is measured on the y-axis from the lowest y value. Here's the lowest point. Here's the lowest y value. Here's the highest point. Here's the highest y value. From the lowest, -2, to the largest, +6. So I'm going to write okay, so for problem 85 on page 231, domain -2 to 6, range -2 to 6. Let's look at 82. Can anyone give us the domain for 82? Notice that this is an open point. It's not a full point. I'm sorry? Sure. So for 82, you see this is an open point, which means -6, it will not be a bracket, but what? A parenthesis. Correct, very good. And it goes all the way till 0. Is it a full point? So then in the domain, please write it down, parenthesis, -6, comma 0 with a bracket. What will be the range? From the smallest y value, which is -3 with a full point, till the largest y value, which is 4. So one more time, the domain between -6 and 0. And the range, so at -6 parentheses 0 bracket. And the range will be between -3 with a bracket and 4 with a parenthesis. I have a question for you. I would like to determine f of, they say here, -4. Okay, let's determine f of -4. What do I do? What is given in the question when I'm asked find f of -4? X is given, right. So how much is it? How much is x? So I imagine that I draw, or I draw a vertical line at -4. I draw a vertical line at -4 and I read the y value. It intersects the function right here, and you're correct, is 0. What if I want to determine f of -5? Exactly, because I draw a vertical line, it crosses the graph in this point, and I will be reading 2. So this point has also a name, a very important name. What is the name of this point, which is -4, comma 0? Awesome. What is the very important name of this point, which is 0, comma -3? Very good. So let's write this down. Also, one more question on the same problem. Let's say I would like you to determine, oh, oops, okay, I have to stop. Sorry.